In this video, we're going to look at how we can multiply and divide fractions. You'll find at the end that they share a lot of similar things, and they kind of belong together, so we'll kind of teach them in tandem here. All right, so let's start with multiplying. So let's take something very simple. 1/2 times 1/2. Right? Now, if we think back to what is the meaning of multiplication, right, you can kind of think of it as being groups of, right? If I said 2 times 4, right, we could think of that as 2 groups of 4, okay, or 4 groups of 2, right? So it's groups of things, okay? So with multiplication of fractions, right, it's a similar thing. So 1/2 times 1/2, we can think a half group of a half. All right, so let's kind of see if we can picture that visually. Okay, so take, like, let's say you had a standard, let's say like chocolate bar. Okay, actually let's do a rectangle to make it look a little better here. There we go. Okay, so I had a bar of chocolate, right, and I have half of it. So I'm going to cut that in half, like so. Okay, so we only have half of that bar left. One part's been eaten already. Okay, and you decide that you're going to share that with your friend. So we're basically taking that half and we are going to cut it in half, like so. Okay, so then I get this half and my friend gets the other half. All right, so what fraction represents the part that I get? If I'm getting half of a candy bar, right, and we can represent that 1/2 times 1/2. Well, if we take a look, right, I'm getting 1, and how many total pieces is the whole candy bar split into? It's split into 4. Okay, so we can see visually that 1/2 times 1/2 is equal to 1/4. All right, sometimes that's referred to as the area model for multiplication as well. Okay, now if we look at what pattern we see, well, what we should notice is that if I look at my numerators, right, oops, I keep selecting the square. Let's try that again. If I look at my numerators, there we go. All right, well, 1 times 1 is 1, right? So I'm really just multiplying my numerators. Same thing is true with my denominators. Okay, if I look at my denominators, right, well, 2 times 2 is 4. Okay, so when we multiply fractions, we're just going to multiply the numerators, multiply the denominators. Okay, let's look at one more example of that. Again, I'm going to start with my rectangle here. Okay, and I'm going to, let's split it into thirds as best I can here. Okay, this isn't going to be perfect, so we'll just pretend those are the same size. They're pretty close. Okay, so I've got, let's select like 2/3. Okay, so we could use the same scenario, a candy bar. I've got 2/3 of it left. Okay, and this time I've got 4 friends I want to share that with. Okay, so I'm going to take that and I'm going to split it into fourths. So there's half, and then each half I will split into half. Okay, so like so, right? So now we can see that, let's see, I'm going to select, this will be my piece, so I get 1/4 of it. So these will be my pieces here. Okay. So if we look at that, we can see what's going on, right? If I count all of the pink rectangles, okay, I see that there are 12 total. Again, that's reinforced with our idea that 3 times 4 gets us our denominator, right? If I look at how many pieces of the candy bar I get to eat, right, I've got the 1 there and the 1 there. I've got 2, right, which happens to be 2 times 1. Okay, to get 2/12, which then can simplify to 1/6. All right, so we can see mathematically and with the area model that we simply multiply our numerators, multiply our denominators. Okay. Now, a lot of times when you're multiplying, you'll end up having to reduce. So we're going to look at a quick shortcut for dealing with that. Okay. So let's say we had something like 2/5, and I want to multiply that times 5/8. Well, if I multiply that out, I end up with 10/40. Okay, and both of those I end up having to, I can divide by 5 to get it down to 2/8, and then I can divide by 2 to get it down to 1/4, or I could divide them both by 10 right away and get them down to 1/4. Okay. Now, sometimes, especially if the numbers get bigger, right, and it's tough to find those greatest common factors. Okay, sometimes it's easier to reduce beforehand. Okay, we call this cross-reducing. So I'm going to show you a technique called cross-reducing that we can use to help make the reducing part a little bit easier. Okay, so essentially with cross-reducing, what I want to do is I want to look at things diagonally. See if I can make this work here. Oh, there we go. So I want to look diagonally at the numbers. Okay, so I'm going to look at, first I'm going to look at 2 and 8. Okay, and I want to ask myself, there we go. I knew I could do it. I want to ask myself, is there anything that I can divide out of both of those, right? Because essentially what I'm doing is I'm doing 2 times 5 over 5 times 8, right? So just like when you simplify a fraction, I can simplify in that form. Okay, so 2 and 8 are both divisible by 2. So what I'm going to do is I'm just going to cross out 2, and I'm going to think 2 divided by 2 is what? Well, in this case, 2 divided by 2 is 1. 8 divided by 2 is what? Well, 8 divided by 2 is 4. Okay, all right, then I'm going to look the other way. Okay, I'm going to look diagonally this way. See if I can do this a little bit faster this time. Okay, and I'm going to ask myself, there we go. I'm going to ask myself, close enough. What can I do? What's divisible, or what can go into both 5 and 5, right? What are factors of 5 and 5? Well, it's 5, right? So I'm going to go 5 divided by 5 is 1. 5 divided by 5 is 1. Okay, now I can multiply. Okay, and if you do this correctly, right, you're basically simplifying before you multiply, so it makes it usually easier because, again, the numbers are smaller before you multiply than after you multiply. So 1 times 1 is 1. 1 times 4 is 4, and we end up with that 1/4. Okay, so we can cross reduce before we multiply in order to prevent or save ourselves some time from simplifying at the end. Let's do one more example of that. Let's do 9/10 times, let's do 5/6. Okay, so again, we look diagonally at the 9 and the 6, right? What's a number that can be divided into both of those, or what's the greatest common factor of those two? Well, it's 3. So 9 divided by 3 is 3. 6 divided by 3 is 2. Okay, then I look this way, 5 and 10. Right? What's the greatest common factor of 5 and 10? Well, it's 5. Right? 5 divided by 5 is 1. 10 divided by 5 is 2. Okay, now I can multiply. 3 times 1 is 3. 2 times 2 is 4. Okay, 3/4. Right? Had I not done that, I'd end up with 45 over 60. Right? To me, that's a little bit tougher. You know, a lot of people can look at that and figure out, well, it's 15 is the greatest common factor. But if you can't, then you have to go through multiple steps. So again, if you keep the numbers smaller and reduce first, right, it just makes it a little bit easier to do, and it saves you a little bit of time there. So, okay, so that is multiplying. Okay, let's look at division. All right, now division is a little bit tougher to kind of picture. Okay, imagine, for example, I had a measuring cup. Okay, and that measuring cup was a half a cup. Okay, if you're doing baking, that's a pretty common measurement. Okay, I have a second measuring cup, and that one is a little bit smaller, and it is 1/4 of a cup. So a division problem might be, I need a half a cup of flour, but I only have a 1/4 cup. Okay, so I've got to take that half cup of flour I need and break it into groups of 1/4. That's what division is, right? If I do 6 divided by 2, okay, I'm basically saying break the 6 down into groups of 2. Well, how many groups of 2 make 6? That's 3, right? So if I do 1/2, let's get rid of the label here. If I do 1/2 and I want to divide that by a fourth, right? I'm basically saying, well, if I how many groups of 1/4 make up a half, right? And we can probably figure out if I dump a fourth in and I dump a second fourth in, that's going to equal a half. A fourth plus a fourth is a half. Okay. If we want to draw that, right? So if I need, half of the box, it takes 2/4 to make that half. All right. So sometimes division is a little bit counterintuitive, but if you can kind of think of it in terms of you're making groups of things, like it takes 2 groups of a fourth to make a half, it makes it maybe make a little bit more sense. Now, mathematically, okay, what we're going to do is we're going to kind of think of some relationships between multiplication and division. Okay, if I said, for example, if I had the number 4 and I multiplied by a half, I get 2. Right? 4 over 1 times a half is 4 over 2, which is 2. Well, it turns out that if I take 4 divided by 2, we also know that's 2. Okay? So because those are equal to each other, I know that 4 times 1/2 is going to be the same as 4 divided by 2. Right? If I take 9 times a third, okay, that's equal to 3. A third of 9 is 3. Well, that turns out to be the same as 9 divided by 3. Okay, so again, I know 9 times a third is equal to 9 divided by 3. All right, so we can start to look at that and develop, see a relationship there between multiplication and division. Okay, so a couple things to note here, right? I've got a 4, I've got a 4. I've got a 9, I've got a 9. Those things don't change. If I think about both sides of the equations there, those don't change. Okay, what is changing? Well, we see that multiplication becomes division, my bad. And same thing here. Okay. And then the most important relationship is that third number. Okay. 1/2 becomes 2. 3 becomes, oops, I highlighted the wrong thing. Let's try that again. There we go. 1/3, there we go, that's the right thing, becomes 3. All right. So let's talk about those numbers. 1/2, 2. 1/3, 3. Okay. And maybe visually, if you think about a whole number as being over 1, all right, we might see that relationship there. Right. If you notice, the second number is basically the first number with the numerator and the denominator flipped around. Okay. There's a term for that, and that term is reciprocal. Okay. So mathematically, a reciprocal by definition is what you multiply a number by to get 1. Right? 1/2 times 2 over 1 is equal to 1. Okay. 1/3 times 3 over 1 is equal to 1. Okay. 2/5. What would I multiply 2/5 by to equal 1? Well, if I flip those around, right, my reciprocal is 5/2. Okay. That's 10 over 10, which equals 1, right? So reciprocal by definition is what do you multiply something by to get 1, right? In reality, we're looking at just kind of flipping the numerator and the denominator, okay? If I have a mixed number, 2 1/3, what's its reciprocal? Well, 2 1/3 is equal to 7/3. The reciprocal of 7/3 is 3/7. So 2 1/3 times 3/7 would be equal to 1, okay? All right, so if we go back to that page where we're looking at the relationship between multiplication and division, what we can see is that when we divide a number, we can get the same result by multiplying by its reciprocal, right? Dividing by 2, I can get the same result as multiplying by a half. Dividing by 3, I can get the same result as multiplying by a third. So I can apply that then to multiplication and division. Okay, so let's say I had 2/3 and I wanted to divide by 3/4, right? So mathematically, right, if we apply that relationship between division and multiplication, we can solve this problem, right? So 2/3 divided by 3/4. Again, we know dividing by a number is the same as multiplying by its reciprocal. Okay, Mathematically, those two things are going to be the same, just like dividing by 2 is the same as multiplying by a half. Okay, so when I divide a fraction, I'm going to multiply by the reciprocal of that second fraction. Okay, and then we can go through, no cross-reducing we can do. Okay, just 2 times 4, 3 times 3 to get 8/9. Okay, let's look at one more example. Let's say we had 7/8, and I wanted to divide by 1/3. Again, mathematically, right, I would multiply by the reciprocal. Dividing by 1/3 is the same as times 3. Okay, and if it helps, put that over 1 there to help as a place value. Okay, again, can't cross-reduce anywhere, so I just get 21/8. Right, as a mixed number in certain cases, so that would be 2 with 5 left over, so 2 and 5/8. Okay, so multiplying, right, we just multiply the numerator, the denominator, do your cross-reducing. Division, we saw, is related to multiplication in that when you divide something, you can get the same result as multiplying by the reciprocal. So we're going to take a division problem, turn it into multiplication, and multiply that by that reciprocal to get our answer.